ever pondered the intricacies of how data is managed in the realm of computing? It's a fascinating world where the concepts of lookup, allocation, and the management of new structures play a crucial role. These may sound complex, but in essence, they're not much different than everyday tasks you engage in. Imagine you're searching for a friend's phone number from a list you have. You scan through the list until you find the friend's number. In computing, this is what we call a lookup. It's the process of seeking out a specific item or information in a data structure. You could be searching in an array, a list, or a vast database. The principle remains the same. Now consider the moment you buy a new bookshelf. You begin by assigning specific shelves for different types of books. Fiction on the top shelf, non-fiction on the bottom, and so forth. This is allocation in a nutshell. In the world of computing, allocation primarily refers to memory allocation. It's a process where a program reserves memory space for variables, data structures, or processes to utilize during execution. Lastly, let's think about managing a garden. It requires planting new seeds, watering plants regularly, and removing weeds to ensure the garden thrives. This is akin to the management of new structures in computing. It involves creating new data structures like arrays, linked lists, or trees, allocating memory for them, and ensuring efficient use and cleanup when these are no longer needed. So, when dealing with new data structures in programming, you might find yourself looking up existing structures or elements within them based on certain criteria. Or you might allocate memory or resources to create new structures dynamically as per requirements. And of course, you'll manage these structures, organizing, updating, accessing, and releasing resources efficiently to avoid memory leaks or inefficiencies. In essence, understanding lookup, allocation, and the management of new structures is a cornerstone of programming. It's how we handle data, optimize resource usage, and maintain system performance. Just as you organize and manage physical items in your everyday life, programming involves similar concepts applied to digital resources and data structures. So, the next time you're searching for a phone number, allocating space on your new bookshelf, or managing your garden, remember, you're not just doing everyday tasks. You're engaging in the fundamental concepts that underpin the world of computing.